Hello friends, today we are going to solve question of stiffness matrix method. So a frame is given here. AB there is point load of 80, BC there is a UDL, in CE there is a point load again of 60 kilonewton, and in CD there is no any load. So at first we'll be writing how many we need redundant reaction. So for that dk is equals to 3j minus r plus m. This formula we'll be using. We get 3. So we have to now draw 3 frame in which redundant reaction z1, z2, z3 will be given. So at first let's find a fixed moment for all these members. And for A we will getting minus 35.55, BA 17.78, BC that's minus 53.33, CB 53.33, FMC CE minus 28.8, for EC 43.2, and for CD there is no any load, so it will be 0. Now let's do next step. Since we'll be finding M1 in AB, there is a Z1 for AB and BC reaction. So for this, when it will be moving, it will move from downward, and when this one reaction will be moving, it will move from this side. So this is the figure for this one, and the reaction will get 4 by 3 to the starting point, and for ending it will be 2 by L as it is shown in this figure. The rule is given here. The reaction will be 6 theta by L square for this, and 6 theta by L square for this one. And for deflection case it will be 12 by del by L cube deflection, and rotation of 6 del by L square. So we'll be finding K11, K21, K31 for this Z1 part, Z1 at B, Z2 at C, and Z3 at D. So K11 here at B, right? So at B there is 4 by 4 and 4 by 3. We'll be getting this one for 2, 1, K21, Z2. Z2 there is 2 by 4, only one. So only one moment. So we'll get this value. Now M2 for at Z2, as this rotation will be here, so it will go up to here and it will go upward. It will come here, it will come here, and it will go here, so it will come downward. So we will get this sort of figure, and the moment will be 4 by L, and for the starting point, and for another side it will be 2 by L, likewise for all of these. And K12 at this point at B, we will get 2 by 4 at C. Z2 at C, it is 4 by 2. There are 3 points, there are 3 moments, so we will get 3.8 and for Z3 at D we are getting 2 by 2. So K3 2 is EI. Now for Z3, since in this figure it is, we have kept here clockwise, so it will be moving upward only. So we have only one on these sorts of moments. So starting point 4 by L, another side 2 by L, and at B there is no any moment, so 0 for C. There is 2a by 2. We'll be writing for Z3 we have 4a by 2, so after solving we'll get this value. Now R1P means fixed in moment at this point, R2P means this point, R3P means this point. So at joint B we'll be writing the fixed in moment. At joint C, summation of joints at C, so we'll get 24.53. At this D, fixed in moment is 0, so and P1, P2, P3 value will be 0 since no any other moment or deflection is given. We have just took all the moments part only, so there's no any need of any deflection, and we'll be using the formula K1 on Z1, K1 to Z2 plus K1 3 Z3 plus R1P is equals to P1 K2 1 Z1 K2 to Z2 plus K2 3 Z3 plus R2P is equals to P2 K3 1 Z1 K3 to Z2 plus K3 3 Z3 plus R3P equals to P3. We'll be substituting all this value and we'll solve this in calculator. We'll find the value for Z1 Z2 Z3, and now we'll be putting all this value in a table. For all the FVM we have found an M1 at AB, M2 at AB, M3 at AB we'll be finding, and final moment formula FEM plus M1 Z1 plus M2 Z2 plus M3 Z3 we'll be solving and we'll getting the values here. And in this part M1 we have found at AB 2 by 3 AB, so AB part is here only. M1 AB 2A by 3 BA it will be 4A by 3, so M1 4A by 3. Likewise we have done for F2 and